Electrostatic forces. Coulomb's law talked about electrostatic forces, and it stated that the electrostatic force between two charges is proportional to the product of the charges or their magnitude, and is inversely proportional to the square of the distance between them, or it can be written as Fe equals Kc Q1 Q2 over R squared. So the electrostatic force is directly proportional to the product of the charges, and it's inversely proportional to the square of the distance of separation between them, where Fe is the electrostatic force measured in newtons, Kc is Coulomb's constant. It has a constant value which is 9 times 10 to the power of 9 newtons meters squared per coulomb squared. Q1 and Q2 are the charges in the objects measured in coulombs, and R is the distance separating the charged objects. It is measured in meters. Let's see how to apply this formula. Consider two charged objects carrying charges of QA, negative 2 microcoulombs, and QB is 4 microcoulombs, positioned at 5 meters away from each other. So we have the magnitude of the first charge, the magnitude of the second charge, and we have the distance separating them. Part A, find the electrostatic force between the two objects, and part B, describe the nature of the electrostatic force. To find the electrostatic force between the two objects, since we have the magnitude of the two charges and the distance separating them, then we can use the formula of Coulomb's law. Fe equals Kc Q1 Q2 over R squared. Now we replace Fe equals Kc is a constant, 9 times 10 to the power of 9. Q1, we replace it, negative 2 times 10 to the power of negative 6 after we convert it from microcoulombs to coulombs. We do the same thing for the charge of B, 4 times 10 to the power of negative 6, converted, over 5, which is R, to the power of 2, or 5 squared. And we get the answer as 2.88 times 10 to the power of negative 3 newtons. Now we have to describe the nature of the electrostatic force. When we talk about the nature of the electrostatic force, it means that we have to mention, is it a force of attraction or a force of repulsion? Since the two charges are of opposite polarities, then the force is attractive. As you see, QA is negative 2, QB is 4. So they are opposite polarities. This one is negative, this one is positive. Unlike charges attract, so it is a force of attraction. Exercise 2. Consider two charged objects carrying charges of QA negative 5 microcoulombs, QB negative 7 microcoulombs, positioned at 5 meters away from each other. Again, we have QA is given, QB is given, and R is given. Find the electrostatic force between them and describe the nature of the electrostatic force. We apply Coulomb's law, we put the formula and we replace. Do not forget to convert, and we get the answer as 0.0126. The nature of the force, now they are both negative. This one is negative 5, this one is negative 7. So it should be a force of repulsion. So the force is repulsive. Exercise 3. A balloon when rubbed against denim gains a charge of negative 10 nanocoulombs. Find the force between the balloon and the denim when they are separated at the distance of 8 centimeters. Okay, we have one charge only, which is the charge of the balloon. Okay, let's think of it. Before we rubbed the balloon against denim, it was neutral. The balloon was neutral, and the denim was also neutral. So the balloon gained this amount of a charge from denim. It means that the denim has lost the same amount of charge. So if the balloon has negative 10 nanocoulombs, then denim has positive 10 nanocoulombs. This is the first point. Now the second thing, they are separated at a distance of 8 centimeters. We have to convert this into meters. From centimeters to meters, you multiply by 10 to the power of negative 2, which is equivalent to dividing by 100. Same thing, we apply Coulomb's law. Kc is constant, 9 times 10 to the power of 9. Q1, which is negative 10 times 10 to the power of negative 9, which is the charge of the balloon. Q2, which is the charge of the denim, which is positive 10 times 10 to the power of negative 9, over 8 times 10 to the power of negative 2 squared. We converted the distance from centimeters to meters, and we get this amount. Now, the nature of the force, one of them is negative, the other one is positive, so they attract. The force is attractive.